confusing. I don't think I definitely still think they're 100% doable, but you got to pay attention to all the details. Okay. So let me clear this, and let's look right here. So let's do a little bit of a warm up here. Okay. Let's look at this screen here that you see. Okay. Root 3 over 2. Let me just write some stuff in green right here. Okay, root 3 over 2 is going to be 8, 7. Okay, root 2 over 2 is going to be 0.71 roughly. Okay. And I should be doing, my bad, 0.87 and 0.71. Okay. This is going to be 0.71. -0.71 negative 0.87. Okay. Now, if you look at all these sign values here, okay, if you look at all these sign values going all the way around the unit circle, okay, all those sign values fall between, this is very important to note, all those sign values fall between -1 and 1. Okay? Those sign values never go beyond -1 and 1. Okay? All right. So let's carry that forward into what I'm going to show you here. Now, let's look at A right here. Okay. I'm going to draw a generic, I'm going to just draw a triangle. There's a 120 here, so that's obtuse angle. Okay. And that's going to be B, uppercase B, which means lowercase b is right here, and they said it's 2. Okay. C, I don't care where you put it. Okay, you can put it here or here. I'm going to put it right here, and we're going to say C is 8. Okay, now right off the bat, you can just eyeball this. Okay, does this even make sense? The answer is no. It doesn't make sense because B has to be, B is the largest angle. Okay, there cannot be a larger angle than 120 in this particular triangle because the angles have to add up to 180. Okay, so B is the largest angle, which means lowercase b has to be the longest side. Okay, the longest side is across from the largest angle, and this is not the case. Okay, B is not the longest side because B is equal to 2 and C is equal to 8. B is less than 8. Okay, B is smaller than C. So this triangle is impossible. There's 0 triangles exist. Okay, that doesn't make sense. Okay, but let's show this mathematically. Okay, so watch this. I'm going to do sine of 120 over 2 is going to equal to sine of c over 8. All right, and I'm going to cross multiply. Okay, I'm going to cross multiply this, and I'm just going to jump straight to it. Okay, after you cross multiply, you are going to get, if after you cross multiply and divide by 2, so I'm going to go sine of 120 on my calculator times 8, divide that by 2, and I get 3.46. Okay, and we're going to inverse sine this. Okay, I'm going to inverse sine this. Now here's the question. Is there such thing? Here's the question I want you to imagine in your head. Is there such thing where there's a sine value? Is there such angle where the sine value is 3.46? Guys, we already established earlier that sine values have to be in between -1 and 1. Okay? There are no sine values in the units. There are no sine values in the unit circle. Okay? No green highlights exceed or go beyond the boundaries of -1 and 1. Okay? Yet, this problem is asking for 3.46 for a sine value. So this is impossible. Okay? There's no such thing as an inverse. There's no such thing as an angle where the sine value is 3.46. So therefore, we showed mathematically, in addition to visually, that 0 triangles exist. Okay? Now here's a case where 2 triangles exist. Okay? Watch this. Now, I want us to just pay attention to the top quadrant 1 and 2. Okay. Now, let's look at this 1/2. Okay. What angles have a sine value of 1/2? Okay. The answer is 30 and 150. Okay. 30 and 150. Okay. Let's look right here. What sine values, or excuse me, what angles have a sine value of roughly 0.87? Okay. The answer is 60 and 120. Okay. All right. So the moral of the story is, for every sine value on the first quadrant, there's also an equal sine value on the second quadrant that's reflected, okay, that's horizontally reflected. Okay. So 60 degrees, if you horizontally reflect it, you get 120, and they both share the same sine values. Okay. So let's hypothetically think of, let's say that there was 23 degrees. 23 degrees. Let me write it here as it should be, as it should have been. What degrees also, what degrees on quadrant 2 also shares the same sine value as 23? What degree also shares the same sine value as 23 degrees? Well, it's somewhere here, because you reflect it, okay? Because you reflect it you reflect it horizontally, okay? And the way you find that, why don't you just do 180 minus 23, okay? And you get 157. So 157 and 23 share the same sine values. Okay. 157 and 23 share the same sign values. Okay? And you can keep, so long story short, every sign value on the quadrant 1 has a horizontally reflected sign value on quadrant 2. Okay, that's the moral of the story. Now, let's look over here. Okay. Let's see. Let's look at B over here. Hang tight. Boom. There we go. And let me draw that right here. Boom, boom, boom. Okay. And let's go with A, B, C. Okay, so that's our generic triangle right there that we're going to start with. Now, A is 6. Okay. Uppercase A is 28. Lowercase c is 10. Okay. Now watch this. Okay, let's do the same thing. Sine of 28 over 6 equals to sine of c over, okay, sine of c over 10. Okay. Now I'm going to cross multiply and do the same thing. I'm going to skip ahead. Sine of 28 times 10 and then divide it by 6. Sine of 28 times 10 and then I'm going to divide it by 6. And I get 0.78. C is roughly 0.78. I should say sine of c. Okay. And then I'm going to do inverse sine. And I get, let's see what it equals to. C is roughly going to be 51.26. Okay? Now, remember, so 51.26 roughly lands us here. Okay? 51.26 roughly lands us here. But remember, there's also going to be a horizontally reflected, okay, angle on the second quadrant that also has a sign value of 0.78. Okay, 0.78 is going to be shared by 51.26 and also let's do 180 and minus 51.26 and 128. Whoops. It's going to be also, it's going to be shared by this 128.74. That angle, which is called 128.74. Let me do it in green. Okay. So before I mistakenly called it this angle here. It's not that angle. It's called this. Of course, you refer to it. I think this goes without saying. You call that green angle this one, which is 128.74. Okay. I was just drawing it incorrectly earlier. Okay, so 128.74 is the other angle that's reflected. Okay, so now we're pretty much, that's the hardest part now. Okay, once you understand that, everything else is pretty easy. Okay, or C is 128.74. Okay, so in that case, you just draw a 128.74 would look like this. Okay, so this is 28. Everything else stays the same. C equals to 10. And this is 128.74. And this is 51.26. A is 6. A, B, C. So the givens are going to be in yellow. Okay, boom, 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 boom. And what we just discovered is this. Okay, and now after this, you're not done. Okay, this is the hardest part, but you're not done. All you have to do after this is find the remaining. Okay, obviously you subtract from 180 to get the pink angles. Okay, and then just use law of sines one more time. Use law of sines one more time to find the pink sides. And that's it. Okay, so we're not done. You got to do a couple more things that we just did in the previous set of problems. Find the remaining angle by subtracting these angles from 180 and use law of sines one more time. The key thing to remember in this one is that for every angle that you get, okay, there's going to be in quadrant 1, there's going to be a reflected angle in quadrant 2 that also shares the same sign value. Okay. Okay, folks,